we need to calculate distance between skew lines. Now to understand what is skew line, so we know there are parallel lines which never intersect and they are in a single plane. So that's a single plane, right? Now we have a intersecting line again talking in a single plane. So these two lines, let's say, intersect with some angle or some common point of intersection. Now if the line lies in two different planes, then they will never intersect even though they are not parallel. Let's take a cube. Okay, let's suppose this is a cube given and we have one line in this plane and another line, let's suppose, in the top plane. Okay, so these two lines, this line 1 or line 2, will never intersect even though they are not parallel, and such lines are called as skew lines. So we need to calculate the minimum distance between these two skew lines. So we need to calculate minimum distance. Okay, so now whenever we want to calculate distance, we'll first draw the diagram to have a better understanding. And if you haven't checked out my last video on how to calculate distance from a point to a line, then you must check out before understanding this. See how we can design or how we can draw this diagram. So what we have a line 1. Let's say this is line 1, and to define line 1 in vector we need at least one point. So let's say this is A with point A1 and a parallel vector, let's say B1. Similarly, we will have another line. Let's suppose this is line 2, and again to define this line 2 in vector we need point. So we'll call this as B, which has coordinate A2 and a parallel vector B2. So how we can calculate minimum distance? Okay, so from, let's suppose here we have a point, and to calculate minimum distance we'll draw perpendicular to this line from this point, right? And similarly, to calculate a distance from this point to here, we need to draw perpendicular line. So we need to find a point where if we draw a line to L1 and L2, it should be perpendicular to both, and this is what we need to calculate. So let's suppose this is point P and this is point Q, so we need to find this distance. Let's suppose that's D. Okay, so we need to calculate length of PQ. We need this value. Okay, now what in other information we have? We can connect these 2 points A1 and A2 as we have connected in the last one, which is distance from a point to a line. Okay, so let's see how we can use this information to calculate the length of PQ. So we see that length or line PQ is perpendicular to L1 and perpendicular to L2. So what kind of line is perpendicular to two lines? So that is, we know it's a vector product of two lines. So what we can say, B1 cross B2, whatever vector it is parallel to, right? It is parallel to a line PQ. So this information now we know that B1 cross B2 will be parallel to line PQ. So about AB and PQ, we see that PQ is just a projection of AB. So PQ is projection of AB. So we know that to find a projection, let's suppose we have PQ and it's a vector. So it's a projection of AB. It's a projection of AB. So we need magnitude of AB and direction of PQ. So what will be the direction of PQ? So PQ is parallel to B1 cross B2. So it's a vector B1 cross B2. So we need its magnitude. So we'll write here B1 cross B2. It's a vector and divide by its magnitude. So we'll have our direction. So this will give direction and this will give a magnitude, and then we'll have our PQ, and this is what we need to calculate. So we'll just substitute and just find the value of AB. So what is AB? AB is nothing but A2 minus A1, and here this cross represents dot product because we need to take dot product with this vector. because we are taking projection. So a2 minus a1 dot b1 cross b2 gives us the vector, and since we need it in direction of, so we need to divide by the magnitude of b1 cross b2, and that's our PQ. It's a simple formula to remember, and since we need magnitude, so we'll just take the magnitude of this and not the vector part, and that's our solution, or that's our formula to find distance between skew lines.